Hello dear, how are you all? Today we learn how integration is the reverse process of differentiation. Suppose we have some function, for example, we have y is equal to x square and we have y is equal to x cube plus 2 x plus 5 and we have y is equal to x raised power 4 plus 5. Suppose we have some function, we will find their gradient function by differentiating. To differentiate all these, we use here power rule. You know, when we use power rule, for example, if we have a function f of x, x raised power 4, we use power rule to differentiate this function. How can we use power rule? We just multiply the function with power of function and then decrease by power 1. We multiply the function. If f of x is a function, f prime x denote its first order derivative or its gradient function. We write f prime x will be equal to, we multiply the function x to the power 4 is called a function with power 4. We multiply the function with power of function, that is 4. After this we decrease the power of function 1. It is called gradient function or first order derivative of the function f of x equal to x raised power 4. Similarly, we use here power rule to find the gradient function of all of these functions. Now, the gradient function are dy by dx or first order derivative, which is when we apply power rule 2x. Here dy by dx is equal to 3x square plus 2 and derivative of x, which is 1, derivative of any variable with respect to itself, which is 1, and derivative of 5, which is constant, which is 0, derivative of any constant, which is 0, hence derivative of 5 is 0. In third case, dy by dx 4x raised power cube. Suppose for some time we are only given these gradient function and we don't know any idea about these actual function. Suppose for a while we are given only these gradient functions and it is asked to us find the actual function. We have to find actual function whose gradient functions are given. I mean to say, we don't have any idea about these actual function and we want to find these actual function by these gradient function. Suppose we are only given these gradient function and it is asked find the actual function whose gradient functions are given. For a little bit of time you will surprise, you will think, how did we find these gradient function? Definitely you did find these gradient function by differentiating. You know, differentiating is a process by which we find the gradient function of any function. So in order to find the actual function, we have to search such an operation that will be the reverse process of differentiation. And this reverse process of differentiation is called integration. In integration problem, we have to check whose differential or derivative is given, which is to be integrated. We know, suppose we have a gradient function and we want to find its original function. Suppose we have a gradient function dy by dx is equal to 3x squared plus 2x. It is a gradient function and we now want to find actual function whose gradient function is given. We now apply here the process which will be the reverse process of differentiation, which is called integration. We have to integrate this function to find the original function whose gradient function is given. For example, in differentiation, when we find the derivative of the function f of x is raised power x raised power 4, in differentiating we apply power rule. Its first order derivative or gradient function become 4 x raised power 3. We multiply the function with power of function and then decrease power 1. But in integration, we have to do a process which will be the reverse of differentiation. In differentiation, we just multiply the function. We just multiply the function with power of function. But in integration, we divide the function. We divide the function with power of function after increasing 1. In differentiation case, we decrease power 1, but in integration, we add power 1, we increase power 1, and then we divide the function by same number. For example, when we integrate this, we divide the function with the power after increasing 1. After increasing 1, when we increase the power of x square by 1, we get x cube. We divide the function by 3 or cube. For example, its power x raised power 2. After increasing power 1, we get cube. We divide the function with cube or 3 and then increase its power by 1. Suppose we have a function y is equal to, or we write, we have to integrate this 3x squared plus 2x. We use this symbol as an integral or antiderivative of the function. We have to integrate this. How we integrate this? We have to apply the reverse process of differentiation. We take 3 as a constant. We integrate x squared dx plus 2 again as a constant. Integral of x dx. Now we apply the process which will be the reverse process of differentiation. Here we add or increase the power of function by 1 and divided by same number. We get x raised power 2 plus 1 and divide 2 plus 1. Here 2 as same, x raised power 1 plus 1 and divide the function by that number 1 plus 1. We get 3x raised power 3 by 3 plus 2x raised power 2 by 2 plus c. Where come from this c? In differentiation, when we differentiate, for example, if we have to differentiate this x square plus 3x plus 5, its derivative is dy by dx is 2x plus 3 plus 0. Derivative of any constant is 0. In differentiation, we eliminate or we finish this constant. But in integration, we have to add a constant from our side. We have to add a constant from our side. Is it clear? It's now x cubed plus xk plus c. This is the function. This is the actual function whose gradient function is this. In this way, by integrating, we can find a function whose gradient function is given. Integration is a process by which we find the actual function if there is given a gradient function of any function. Thank you.